All right, you are welcome again. We are talking about exact equation under differential equation, okay? And then we are taking a new series called exact equation made easy. Exact equation made easy. In this video, we are showing you how to solve exact equation within a minute, okay? Now let's go. Let's take a look at this problem. It says show that this equation is exact and then solve. Show that this equation is exact and then do what? Solve it. Okay, now let's go. We have x dy dx plus 3x plus y is equal to 0. Okay, x dy dx plus 3x plus y is equal to 0, right? Good. Now let's go. Here let's put this 3x plus y in bracket. When you put it in bracket, multiply both sides by dx, we are going to have x dy plus 3x plus y dx equal to 0. X dy plus 3x plus y in bracket dx is equal to 0. Are we together? Good. Now, by definition, what do we mean by an exact equation? We say that a differential equation of this form m dx plus n dy equal to 0 is said to be exact if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. By definition, right? Good. Now, this part that is having dx, we're going to call it m. The part that is having dy, we're going to call it n. Are we together? Yes. Now, from this equation, we have the part that is having the x is 3x plus y. We say this is m, and then the other side, we have n is equal to x. So we are going to differentiate m partially with respect to y, and then n partially with respect to x. Now, going with that, we are going to see that the partial m all over partial y is equal to 1. When you differentiate 3x with respect to y is 0. Then differentiate y with respect to y, 1. Then on the part of n, partial derivative of n with respect to x. When you differentiate x with respect to x is going to give us 1. Now here you can see that partial m all over partial y is equal to partial n all over partial x. Are we together? Thus, we say that this equation is exact by definition, right? Good. Now, the solution to this exact equation is given as the integral of m dx plus integral of n dy equal to 0. Hello, I explained this concept on our first video on exact equation made easy. Please, I want you to watch that video and then understand these basic principles, okay? Good. Now, let's go. We have that the solution to this differential equation is given as the integral of m dx plus integral of n dy is equal to 0. So that means we are going to integrate m with respect to x, integrate n with respect to y. Bring these two together, it will give us the solution that we are looking for, right? Good. So we are going to have the integral of m is what? 3x plus y dx plus the other side integral of x with respect to y, right, equal to 0. So here when we integrate 3x with respect to x, it's going to give us 3x squared all over 2 plus when we integrate y with respect to x, it's going to give us xy. Hello. Then the other part of the integral, that is integral of x with respect to y. We integrate x with respect to x. When you integrate x with respect to y, we are going to have xy. Then we have plus c, which is equal to 0. Okay, good. So here now, we have two parts of this integral. Let's bring these two together, okay? So bringing these two together, we have 3x squared all over 2 plus xy in the first integral, and then we have xy in the second integral, right? So we pick one of them, okay? So here we're going to have 3x squared all over 2 plus xy plus c equal to 0. Hello. 3x squared all over 2 plus xy plus c equal to 0. So this is the solution to the differential equation x dy dx plus 3x plus y equal to 0. Are we together? Yes. Let's take more examples.